Check, check. Still coming through? There it is. Check, check. 1, 2, 3. Check, check. All right, welcome. Welcome to PyCon. So I am Michael Herman. I do have notes to go through. So first off, I will email out a survey link for this tutorial afterwards, and we're going to be taking a break at 10:15 for you all to get. I can't tell if this is going in and out or not. Is it? So I've been sick for about, I'm getting over a cold right now. Woke up yesterday, my voice sounded like this, like worst nightmare came true. So hopefully my voice lasts this 3 hours. Otherwise, someone out here is going to be teaching it, right? Yay. I'm turned on. I can switch to a regular mic if that, and we can deal with this like. Let me test. Check, check. 1, 2. Check, check. Check, check. 1, 2. Check, check. Check, check. Sounds a bit better. Does this sound better? Is it going in and out now? Better? Okay, cool. All right, should I do that spiel over again? You just want to go right to it? Let's get to it. All right, so when I pitched this talk, I noticed that my spell check was throwing some errors, and I figured out that 3 out of the 4 words in there are like not words. They're just like, I imagine you can guess which words they are. So serverless, OpenFaaS, Kubernetes, definitely not words. Python's a word, so that's good. Yay. But yeah, so we're going to be diving into the world of Flask, Docker, Kubernetes, Docker Swarm mode, and OpenFaaS. Has anyone, just out of curiosity, has anyone heard of OpenFaaS before? Sweet. Has anyone used OpenFaaS? Cool, awesome. I may rest on you a little bit then. Okay, so let's go over the agenda real quick. So I'm going to talk a little bit about myself, go into some objectives, some sort of things that you should be able to take away from this talk. We're going to dive into what we're building. We're going to go over the architecture, talk a little bit about microservices. I'm going to go over a little bit of theory and talk about where functions as a service / serverless slash OpenFaaS fits into the cloud computing model. And by the way, if you can't hear me, definitely let me know, especially in the back. If this goes in and out, I can't tell. So I could just be sitting up here talking to myself, and if no one lets me know. Also, if you can't see the screen, I can definitely zoom in, especially when I get code up there. So just definitely let me know. So yeah, we're going to spend the first 30 minutes just talking a little bit about theory. After that, we're going to dive into Docker, and we're going to actually be spinning up the web app. So again, that's Python, Flask, Postgres, and Redis. We're then going to spin up the OpenFaaS backend, and we're going to spend the next 2 hours talking a little bit about deployment. We're going to be setting up DigitalOcean. We're going to be looking at Docker Swarm mode. We're going to look at Kubernetes, and then I have some challenges for you. And then obviously I have some, you guys can ask questions and whatnot at the end. So a little bit about myself. I am a engineer at a company called ClickFox. They're out of Denver. For that matter, I'm out of Denver as well. And they do big data analytics. If you're curious about more about ClickFox, just talk to me afterwards. So I've been using Docker since I think it hit the homepage of Hacker News. I think that was like 2013, and I started using it kind of like a little bit after that, early 2014. I am the co-founder of, or formerly, I guess, the co-founder of Real Python. Besides that, and I'm into tech writing. I did teach at a boot camp for about 2 years, full stack JavaScript, the Node Express type world. Other than that, I do a lot of open source, and I'm really into a band called Radiohead. How's my voice? It's okay? Yeah, you can be honest. Yeah. I think I had one honest person back there. Everyone else was like, yeah, it's great, it's great. Yeah, that brings me to Chris. Chris, do you want to talk a little bit about yourself?
Hey guys, I'm Chris Louise. Michael and I formerly collaborated. I lived in Denver until this year. I'm a data scientist at Progressive Insurance here in Cleveland right now. And Michael needed a TA, and I was like, hey, I'll come help, but I don't know what you're doing. So I'll help you out as much as I can, and that's what I'm here for.
Cool, thank you. Yeah, again, I woke up yesterday, my voice is like this, and the TA I had scheduled for this was like, I can't make it, so it was just like, man, I don't want to go to this at all. But so, sent out a tweet. Fortunately, my friend Chris here came through. He's not a Docker expert, he is a Python expert. So he's going to help out as much as he can. If you do get stuck and do have questions, just raise your hand. And Chris, if you just want to, go by and see if you can assist. Well, thank you. Okay, so objectives. So by the end of this talk, you should be able to configure and run microservices with Docker. We'll be using Docker Compose for orchestration. We're going to be using Redis Queue. We're going to integrate that with Flask in order to be able to create asynchronous tasks. We're going to be running those tasks in the background with a separate worker process. We're going to be running unit integration tests inside the container. You'll be able to hopefully deploy Flask, Postgres, and Redis to DigitalOcean via Docker Compose and Docker Machine. We're going to then dive into the world of container orchestration and the tools associated with that. So the tools we're going to be using are Docker Swarm mode and Kubernetes. And then we're going to be deploying the OpenFaaS backend. And we're going to look a little bit about how to monitor your functions with a time series database called Prometheus. And we'll pop Grafana on top of that. So, out of curiosity, who is new to Docker? Okay, cool. Everyone have Docker installed? Okay. Is there anyone that doesn't have Docker installed? Okay. Chris, do you want to maybe help those people out? If you just go to docker.com, it's like pretty straightforward. Just download the community edition. Is everyone on the network right now? Anyone having internet access problems? Out of curiosity, is it super slow? Fairly slow. Okay. Okay. So much of this course, or much of this tutorial, comes from a larger course that I wrote called Microservices with Docker, Flask, and React. It's all AWS based. It goes into test-driven development. Everything is deployed on a container orchestration system on AWS called ECS, which stands for Elastic Container Service, and you can use that instead of, say, Docker Swarm or Kubernetes. Half of it is pretty much front end, so go into React and Redux and whatnot. And so if you're interested in a larger tutorial, check out testdriven.io. Okay, so let's take a look at what we are building today. So I call this OpenCI. It's basically a serverless continuous integration system, and it's backed by Python and Flask, and OpenFaaS is being used as the code eval. So it's just really just a Travis CI clone, or Travis CI, Circle CI. Think of any of those CI as a service type tools. And why are we building this? Because it's a little more interesting than a CRUD app. There's multiple pieces that obviously have to come together and work together. On that note, we're not going to dive into any of these tools or technologies. It's all about the communication between them, linking them together and getting them to work together. So I'm going to demo the app real quick. Just refresh this. So the web app portion right now is just running locally. This is Python, Flask, Redis, the worker process, Postgres, and then it's connecting to my OpenFaaS backend, which is spun up on DigitalOcean right now. So the way this works is, typical to Travis CI, you just add a new project. It could be test. This actually won't work because it has to correspond to a GitHub repo, but this is just showing that it actually works, and then you can delete a project as well. So I have a project already set up. I can hit run build. So what that did at that point was that added a task to Redis. The worker process picked up a new task on top of the queue. It sent a request to my OpenFaaS backend. My OpenFaaS backend then cloned down the repo, ran the tests, grabbed the results, and it's spitting it back. And then the worker process is then updating Redis. And meanwhile, my client side is continuing to just check the status just to see if that task is done. A little bit more about the architecture in just a second, but just to show you that it works. So obviously not a very fancy project, just has a test.py file, just asserting that num1 equals num2. So you can see that 22 does not equal 23. If I edit this real quick. Now I do my build. You can see that they pass. So it is actually working. This isn't like a dummy toy project. It is a dummy toy project, but it is a working dummy toy project. So any quick questions on what we're building? Cool. So I don't know if you can see this in the back, but you can kind of see the architecture there. So request comes in, they hit the load balancer, and then they get forwarded onto Flask. Flask then will communicate with the Redis queue. Worker process again will pick up new tasks on top of that queue, and then it will send the request to OpenFaaS. OpenFaaS then has an API gateway. It then will route the request to the appropriate function. There is a sanity check function there as well. And I'll show you what that looks like when we dive more into the application. Okay. Quick questions? Anything? Sweet. Okay, so the architecture, kind of already went over this. The website, Python, Flask. G2 is my production WSGI server. Anyone new to Flask? Those new to Flask, have you used Django in the past? Are you familiar with web development? Yes. Is anyone completely new to web development? A few people? Okay. Okay. So for the web side of things, or the web DB, I'm using Postgres, obviously Redis, the worker processes, Python, Nginx, OpenFaaS backend. The gateway is in Golang, and then the two functions are in Python. Okay, so I sent this out, I think, a couple days ago about going ahead and grabbing the project. If you haven't already done that, go ahead and clone that down. Make sure you're on the PyCon branch, and then clone it down, cd into the project directory, and then run this docker compose command, and that's going to download all of the dependencies for the web side of things. Has anyone not done that? Okay. I know there's more in here, but go ahead and do that now. Does everyone have a link to the slides? Okay. So I'm going to move on while the dependencies are downloading. But yeah, make sure you go ahead and do that. I don't know. Yeah. So we have another TA, our friend Frank. Frank, do you want to come up and just say a few things? Oh, no worries. Sorry to put you on the spot right away. Yeah, yeah.
Hi everyone, Frank. Happy to answer any questions.
Yeah, again, like Frank has a little more Docker experience than Chris. Chris is the other TA. He's more on the Python side of things, but Frank has a little more Docker experience. If you have questions, if you get stuck, please raise your hand. I'm sure other people will have questions, similar questions. Okay, can I move on past this slide? Are we good? Okay. And yeah, I'm using an orchestration tool here called Docker Compose. If you're not familiar with Docker Compose, it basically just allows you to easily link together multiple Docker containers just to get them to talk to each other. Okay, so this is obviously a microservice-y type stack. So why microservices? Some of the pros that you get from microservices, you get the separation of concerns. You can bring whatever language, whatever tool that you want to bring, since usually a lot of times microservices are communicating over. Could be a message bus as well. Errors are like generally isolated to that code base. It's also going to be hopefully a smaller code base if you're breaking apart your monolith. It's a lot easier for juniors to get involved in there. And with localized errors, a lot of times it's like, well, if they muck that up, then hopefully it's just isolated to that individual app or that individual code base. With that, there are definitely a lot of cons with microservices. They are very, very, very complex. If your team is not set up for microservices, thinking in terms of microservices, it's very difficult to go in that direction. I always recommend start with modules over microservices, modules in the monolith. Network complexity. So individual code bases might be less complex, but the complexity is the communication between them. So Ajax and REST, a lot of times what you can have happen is just a ping pong like effect of one microservice calling another microservice. So there could be lag there, and so you definitely need to take that into account. Data persistence is pretty difficult. A lot of times containers are ephemeral. They're easy to bring up and bring down. You don't want to do that with your data, obviously, so you need to figure out a way of persisting your data, whether that's your DB, your queue, service discovery as well, in terms of keeping some sort of some sort of way to keep track of which services have I spun up, and so the load balancer knows about it. Security is definitely an issue. You have more surface area there, so you definitely, there's more areas prone to attack. Testing is difficult. A lot of times people will try and test a microservice like it's a monolith. So being able to spin up all those apps locally to test the full integration or test with end-to-end tests is difficult. Docker can help with that, but if you have third-party integrations there, you have to rely on mocking and stubbing and whatnot, and that can be pretty difficult. Questions on microservices? Anything anyone wants to add? Am I missing something big? Out of curiosity, has anyone helped architect the rewriting or refactoring of a monolith to a microservice stack? Cool. Come chat with me definitely afterwards. I'm curious. I'm kind of doing that right now, and I feel like I'm the only one in the company that understands containers, and so I'm just like, yeah, no, how about you learn containerization first? But pretty interesting. Yeah, at the end of the day, you definitely need strong documentation. Developers don't like writing docs, so that's difficulty. You definitely need a mature DevOps team and lots of planning. So I do have a link down there at the bottom if you want a little more information on microservices. Okay, I'm gonna shut this off because I got a cough real quick, so I don't want everyone to hear that. I guess everyone did hear that since it echoed all over the place, so my bad. Okay, so let's jump into a little bit about theory. We're going to talk about where serverless functions as a service, OpenFaaS, fits into the cloud computing modules, or cloud computing modules. Okay, has everyone heard of infrastructure as a service and platform as a service? So infrastructure as a service is it gives you just the basic architecture or infrastructure that you need. So that could be your compute resources, could be just a straight EC2 instance. Generally handles networking as well as your storage. Some examples are DigitalOcean, Rackspace, parts of AWS, parts of Azure, parts of Google Cloud, or whatever Google's calling it these days. Then you also have your platforms as a service, and these make it just slightly easier for end users to be able to deploy their application. So you could think Heroku, Elastic Beanstalk, Google App Engine was kind of like the main one that I kind of think of. I think that was like the first market or whatever. So this is one image that I'm sure you can't see, but this, let me see if I can zoom in on that. Well, that actually worked. Weird. Okay, so this kind of compares the different cloud computing modules. So if you're dealing with on-premise, you got to deal with all that stuff. Infrastructure as a service, the cloud provider will take care of these things. You are then having to manage these things and so forth. So with platform as a service, you just have to manage your application and your data. Software as a service, you could think like Gmail and stuff like that, you actually don't need to manage any of that. They're managing everything for you. So if you think in terms of control, how much control do you actually need for your application? And so let me hop back. So any questions on infrastructure service, platform as a service? Pretty familiar with those two things. Okay, serverless and functions as a service. So these have come about in the sort of the last couple of years. So serverless is it's a cloud computing execution model that abstracts a lot of the complexity away. And generally pricing is on demand, sort of pay as you go type thing. Where you only have the resource, you're only paying for the resource when it's actually executing. Whereas a platform as a service, when you deploy your application, you're paying for that whether it's getting traffic or not. Whether someone's using it or not, you're paying to rent that space. Whereas serverless function as a service, you're only paying when execution is actually occurring. So it's on demand. It boots up really fast. That said, there are different tiers for like booting up. With AWS Lambda, you have sort of functions that are hot, which are live. You have functions that are warm, which are semi-live, and you have functions that are cold, which are not live. And there's probably even more tiers in there at this point, but you're paying different prices for those different tiers. And basically, um, if say you have an API gateway in front of that, and you may want to have some of those functions hot, so an end user doesn't have to like wait those like few milliseconds for the function to spin up, especially if you have any sort of ping pong effect where that function has to call this function, blah blah blah, hit a database, and then it spins back the or sends back the response. So you may want to have some of those functions already spun up. With AWS Lambda, you have auto scaling built in. Essentially, you have infinite scaling there. I mean, you have scaling that it can scale as much as AWS can handle, which is, in my opinion, probably infinity. But but you can auto scaling is built in, and then it's pay as you go. You can spin down to 0 or bring down your resources to 0 when they're not being used. So functions as services is basic a serverless model that enables developers to run modular stateless pieces of code in response to events. So I like to think of like triggers and actions. If you think like if then this that, you want something to happen and then that will spin up or something. Something triggers that function to spin up. It could be if you're using CloudWatch, you can set a scheduler up there and you can do like some cron like stuff. So the CloudWatch will then be able to trigger that function. HTTP requests. So with AWS Lambda, you have API gateway there. So a request will hit Lambda, or hit API gateway. API gateway then will trigger the Lambda. So yeah, what are they good for? Handling HTTP requests, processing tasks from a queue. That's what we're going to be using it for today, and then cron-like jobs. Okay, let me see if I can open this image up. Oh, cool. Usually I have a lot of problems with zooming on these things, but this thing is just working. So if you think in terms of like your cloud computing module, and then here's your like your application paradigm. So you think of like how that has kind of evolved throughout the years. So you start with like actually nothing, no paradigm, no structure. Then you monolith, MVC type application. There's SOA, service-oriented architecture. Then you have microservices, which build on top of that. And so now you have functions as a service. So if you think about just a basic CRUD app with your create, read, update, delete, you could actually break apart your basic CRUD app into individual functions. Each one of those CRUD pieces could align with a function. And then you can scale each one of those functions as you want. There are actually ways to continue to write your application as a monolith too, and then have like the underlying infrastructure, underlying framework, break it apart when you do a deploy. There's a framework on the Node Express JavaScript world called Serverless that handles that, and then on the Python side of things, Zappa is one that comes. And there's a few others on the Python side of things. Mine's going blank right now, but Zappa, there's a that's for Django and also Flask. But you can actually continue to use the patterns that you're using in Django and Flask, and when you deploy it, it'll get deployed. Each individual function or each individual like route handler or whatever will get broken up into a function, depending on how you delegate that. Cool. Any questions thus far? Okay, so how does FaaS differ from the PaaS model? PaaS, I think I went over this already. So applications are typically running on the server at all times, whereas functions as a service, they are being run as needed, and they can spin up in a few milliseconds. Examples: Talked a little bit about AWS Lambda. That's the one that I'm familiar with. There's also Google Cloud Functions, Microsoft Functions. So FaaS advantages. So since your infrastructure is almost entirely being managed by somebody else, hopefully you have increased velocity. Hopefully your devs can then just work on writing business valuable code. So whatever differentiates your app from whatever the competitors are. They don't have to worry so much about deployment. There's also scalability, availability, fault tolerance that comes out of the box. Those come out of the box with these examples there. There's also, in theory, you'll have decreased costs, no idle resources. It gets very, very complex though with the sort of the cost structures. You get out of the box with AWS Lambda, you get a certain amount of execution time per month free. I can't remember what that is. If it's like 1 million minutes, seconds, hours, days. I can't think of what it is offhand, but it's something ridiculously high. So essentially, you could get good with. And that's the talk. It's back. Okay, cool. We are back. Where was I? So you could essentially use AWS Lambda free. Now the caveat with that is, as soon as you really remember, it's like trigger in action. As soon as you connect it to really anything that triggers it, such as like API Gateway, CloudWatch, you will incur costs there. It's not the cost associated with AWS Lambda. It is the cost associated with that other service that's connecting to it. So if you really want to try and use AWS Lambda, you are going to probably end up paying something to do that. But the actual Lambda functions, you won't be probably paying for a little while. So some of the disadvantages, decreased transparency. Someone else is managing the infrastructure. Who knows what's going on underneath the scenes there? Debugging those functions is not fun. There's lots of moving pieces there. So if you're breaking apart a gigantic app into functions as a service, like, you better hope your dev team is like ready for that, because it's pretty complex. A lot of teams can definitely not handle that. Restrictions. There's only certain language runtimes for AWS Lambda. There's like the big ones. There's a C language, Java, Python, Python 3 that is. Node. I think there's a few more. I can't think of them off the top of my head. Microsoft and Google have the same sort of like restrictions in terms of runtime. There's only a certain amount of languages there. Also, the functions can only run for 300 seconds, at least on AWS Lambda. I don't know if that's changed in the past like 6 months. I haven't looked, so it might have changed. But if you have something like a Spark process that is, or like some sort of like heavy processing task that takes longer than 300 seconds, you got to somehow figure out how to, like, it has to be intelligent enough to know that, hey, 300 seconds is coming up. We have to grab the state wherever it's at, and then recursively call itself or call some other function. And that's not easy to do. You also have vendor lock-in. If you are using AWS Lambda or whatever it is, you will be locked in there. It is not too difficult to move them to like a different provider, but you still do have that initial lock-in. Okay, so that's sort of serverless and functions as a service. Questions, thoughts, concerns, feedback? Cool. What time is it? So I have 7:45, so that's 9:45, right? Okay, all right. If we hit the 10:15 mark and you can definitely tell that I'm not stopping, just somebody raise their hand, because I don't have an alarm or anything that's going off. 10:15 is our break. Okay, so OpenFaaS. So OpenFaaS is a framework for building serverless functions, and that's within containers. So it does help to mitigate some of those disadvantages that we went over with functions as a service. Essentially, you can run these functions in whatever language you want, however long you want, and wherever you want. Since you have Docker behind it, you pretty much can do whatever you want inside the Docker container. So you can have a function really run as long as you want. Wouldn't recommend doing that, but you don't have that 300-second cap. So OpenFaaS is a open source project. It comes from this guy Alex Ellis. He took a job at VMware not too long ago. So I'm kind of feeling like VMware is probably going to come out with an AWS Lambda, type competitor alternative, and is probably going to be backed by OpenFaaS. But yeah, it is completely open source. I think there's like 10,000 stars or something on the repo if that's your sanity check for whether a project is good or not. And there's a huge community of people. There is a Slack channel, a lot of activity going on right now. So I'll get more into OpenFaaS as we build out the application. But really, when you're thinking about your cloud provider, you kind of want to think about how much control do you actually need. If you're just building your basic, CRUD app, you could probably get away with using something like a Heroku, a platform as a service, or AWS Lambda, a function as a service. Do you actually really want to control, all that other infrastructure? You're kind of just reinventing the wheel. I mean, maybe if your product is reinventing the wheel, then maybe you want to do that. I don't know, but you kind of want to think about just how much control that you actually need. You also want to think about your team's strengths and weaknesses. Like, do you have like a lot of full stack developers that enjoy doing DevOps, DevOpsy type work, or do you have like more of a traditional like development team that all they want to do is just code what they're working on, then chuck it over the fence for some other team to manage, and they don't want to touch anything else? Maybe then you would want to steer away, or maybe then you want to steer away from like doing, I guess in that case, yeah, if you have your separate DevOps team, maybe they want to like manage the infrastructure there, or maybe like since they don't want to handle any of that, then maybe platform as a service is the way to go. You also want to, like, it takes considerable time and resources to run on premise. Also with infrastructure as a service, you're obviously having to manage more. So you want to kind of think, do I want to really focus my time and resources on this? Cool. So that's all that I have in terms of the theory around the cloud computing modules. Hopefully you kind of understand where functions as a service / serverless kind of fits in. Questions? Yeah. So OpenFaaS, you're just running a function inside a Docker container. So it's not, you could run that on a single like EC2 box. And so, sorry, I don't know if everyone heard that. The question is, how does OpenFaaS allow you to go over that 5-minute, 300-second mark? It's really, you have complete control over that. So you have more control deploying the OpenFaaS sort of framework, sort of network on your own, and then you're managing that on your own. So if you think in terms of control, it's kind of like in between, I would say, like a function as a service and like a platform as a service, where you have a little bit more control there. So you can run it in whatever language, however long you want, but you're actually going to have to like manage the deployment of it. Is that kind of cool? Good question. Any other questions? Yeah. I'm sorry? I haven't actually looked at that. That's a good question. I mean, you can have them already spun up. So it'll just take as long as it takes to spin up a new Docker container. So if you already have those up, then yeah, you can definitely match that. I don't know what's going on behind the scenes on AWS Lambda. So they have, cold, warm, hot. I imagine they just have those things running in Docker containers at all time. They're probably all spun up, but they just have different pricing structure on top of it. So I assume if you do have those spun up, then you can match that time, but it will just take the time to like spin up the Docker container. Any other questions? And I'll try to remember to repeat the questions, but like my mind is like spinning like up here. So if I forget, definitely call me out on it. Okay, so now we're going to dive into the portion where you guys are going to be spinning these things up, and you all will be spinning these up and connecting them. So let's start with the web app. So again, on the web app side of things, we have our Nginx reverse proxy. We have our actual web app, our API, Python Flask. We're using Redis as the broker for our task queue. We have a worker process, and then we have our database. So we're going to start with the database. So let's take a look at the code really quick. So the way that I have this project structure broken up, if you haven't looked at it already, so I have all my Docker Compose files down here, and then inside my services directory, I have all the services broken up in there. Should be pretty straightforward in here. Web is Flask, Nginx is Nginx, the database is Postgres, and all my my functions are inside of here. So inside the database folder, take a quick look at the Docker file. So I'm just pulling the latest from the Postgres Docker image on Docker Hub, and then I'm running this command or this command add create.sql. And so what this is doing is on the init, it is placing that create.sql file into that directory there. And so when you do that, it runs whatever SQL commands I have in that create.sql file. So that begs the question, what's inside the create.sql file? Okay, so I'm creating my databases. So these are all the databases that I'm in need. I have prod database, stage, dev, and test. So on the init, when that container fires up, it takes that create.sql file. It then runs the create.sql file to create the databases. Cool. Any questions on that? Pretty straightforward. Okay. I'm getting the sense you want me to move a little bit faster, or do you want me to slow down? Am I good? I'm just right? Okay. I don't believe you, but no, I'm kidding. So on my Docker Compose side, so Docker Compose, for those who don't know, is used to connect multiple containers together. So on my DB side, I'm setting a container name of web-db, then also have the image here that I'm creating. I'm naming that web-db. This build the context, again, all of my services are inside that services directory. So this is the context for where the Docker file is going to be, the name of the Docker file. I'm exposing port 5432 inside the container. So I'll think the right side is inside the container, the left side is to the world. So on the right side, 5432, any containers in the same network that are linked to this will have access to Postgres. 5435 is then exposed to the entire world. So when you deploy this, you probably don't want to expose that 5435. You probably just want to expose 5432, so not everyone can access it. This is just my developed Docker Compose file, so I want to be able to access it. So I'm going ahead and exposing it. Environment is used for setting some environment variables, so I have a super strict password there of Postgres. I'm using just the default Postgres username and password there. Again, this is development mode, so we can get away with that. Cool. So to actually spin this up, you would run this command here. Since you already did a build, I'm assuming that this is already up. And so then you can run this sandy check command. So Docker execute is used to hop into a running container. Then using the container name here of web-db, and then I'm just hopping into pSQL here. So let's do this together. So assuming that you are in the OpenCI directory, you can go ahead and run that command. and then do \L, and you can see my Postgres database is there. Questions? Anyone need help? Cool. So that's the database. So moving on. So we have our web app. I'll go over this fairly quick. So in terms of the code, again, this is in the services/web directory. I have my main manage.py file. This is using the CLI or click for creating these commands here that I can run. So I have a create db command, drop db, create admin, and so forth. Some tests and test with coverage. I can also run flake8. And I also have a command here to run my worker process. A lot of people ask me, why are you running your worker process here? Well, because I want the app context. I want to be able to reference the current app within inside of here. I don't think I'm actually taking advantage of that here, so you could run this process separately, but I like to kick this off here just so in case I need to get something, say from like the app level config or whatnot, I like to kick it off from in here. So yeah, that's a question that I get a lot. So in terms of the actual project, that's broken up between client and server. I also have my tests, config file inside the server. I'm breaking these up with just blueprints. So I have my main blueprint, my user's blueprint, and then my models.py file that goes across the two blueprints. You could break this up and put these into the blueprints if you wanted to. So users, obviously for authentication, and I'm using Flask login for that. So it's using a session-based authentication. If I was using React or Angular or anything like that, I'd probably switch over to job-based authentication. But I'm using Genja and server-side templating and whatnot, so I'm fine with that. And then I also have a project model. So again, when you create a new project, it's going to take the name, it's going to take the URL. Status is whether the tests pass or fail, and then that's related back to the user ID. It's just a one-to-many relationship. Inside my main, we can take a look at the views. You know, like pretty straightforward inside of here. So I have my get all requests, so that's going to get all the projects from the database. My post request to add a project, delete a project. This route is for obviously kicking off the grading of a new project. And so this connects to Redis. It's grabbing the Redis URL from the config and adding a new task called create task to the task queue. That takes the project URL. And then that takes the OpenFaaS URL, because again, it has to make a request to OpenFaaS at that point, because OpenFaaS is handling the code eval. Then I have a get status endpoint. So after I kick off the grading, I want to continue to check the status. So it is continuing to basically ping or pulling the API to check the status of that job. Let's see. And actually, this is not correct here. I shouldn't have this build in here. I'm not sure why that's in there. But this will actually update the project at this point when some, actually this should not be in here. Ignore this endpoint for now. I should have pulled that out. So the main endpoint is just for adding, deleting a project, and grading a project, and checking the status of a project inside my tasks. So I have my create tasks. Again, it takes a project URL. So the GitHub URL of the repo takes the OpenFaaS URL, wherever that's located at. I then am splitting the list, grabbing the namespace. So that could be, in this case, it would be testdriven.io. So it's taking testdriven.io and then the repo name. In this case, it would be OpenCI. and then it's using that for the payload, sending the post request to OpenFaaS. OpenFaaS is then doing its magic, which we'll go over in just a second, adding some headers, grabbing the data back, returning the data that gets added back into Redis, and then when the status endpoint says it's done, we're getting that data, and then we're sending it back to the client side. On the client side, so going back to the end user's perspective, using Ginger templating, oh man, this is like a terminal, a JavaScript terminal. I can't remember the name of the what I'm using, but we can look at that real quick. So templates, base. Actually, sorry, that's going to be my home. Templates. Okay, so this is, so I'm using a bit of jQuery in here, and I'll go over that in just a second. But if the user is authenticated, it's going to fire this main JS, and inside the main JS, within my static, so I am running this command term.open, and so this is basically going to create that terminal. So it's just a terminal that lives on the client side, and I'm just taking the results from my tests and then just dumping it into the terminal. So I'm using a little bit of jQuery here. So when you click the button, so when you click the run build button, it's first putting that running into the terminal, which you can see right here. So then it's grabbing that project ID, sending this to the backend, which is a GET request. And after that is done, then it's triggering the get status command. So that's, again, just checking, continuing to check that endpoint just to ensure, just to see that, hey, is this process done? And then here is that get status function. So it takes the task ID, the project ID, doing a GET request. So if the task status is finished, then it's either going to put build pass or build fail there, depending on if the test pass or fail. And then it's also grabbing that results and then dumping it into the terminal. If it's the task failed, then I'm just doing a build fail. That's kind of like a catch-all fail. And then doing a set timeout here, so that way it just gets ran every second. Cool. Any questions with that? Kind of a pretty simple CRUD app, using a bit of jQuery to add a little bit of action there with the user, and communicating with Redis, and then the worker process, which we'll go over in a second. Then we'll communicate with OpenFaaS. So to spin this up, again, if you've already ran the build commands, you won't need to run this, but this will build the image, spin up the container. I am then seeding the database and then adding a bit of data to it as well. And then if you want to do a quick sanity check, you can go ahead and run the unit integration tests. So one thing to note here is if we go and look at the, if we go and look at the Docker Compose file, so on the web side, pretty similar to what's going on the WebDB side, exposing port 5000 inside, 5002 to the rest of the world, adding these environment variables. You can see that depends on. So it depends on in Docker Compose, that will, that's basically saying don't spin up the web container until WebDB is up. So this will wait for WebDB to be up. The caveat with that is it doesn't care if Postgres is up at this point. So if you're doing something right off the bat, like say you're running your migrations, you will get an error here because there is a race condition. One thing you can do is, and if you're curious, ask me about this after. you can have like a basic shell script that does a while loop that continues to ping that endpoint 5435. And it's like in the Docker world, it's called like wait for it. And so it's just basically don't actually spin up this container, or actually don't actually run Python Flask until Postgres is up. So if you are running your migrations right off the bat, I would highly recommend doing that. Okay. I'm doing a lot of talking. Any questions? Anyone lost? Question?
More of a comment. Have you ever run into questions with the database not being ready by the time the web spins up? So I run into that a lot and have to generate like scripts and like test, commands to make sure that the database.
Yeah, that's kind of what I was getting into with that wait for it script. So the wait for it script, I wouldn't run like I wouldn't spin up gunicorn or or like run my migrations until that while loop that's running. I can show you real quick. So inside services, users, entry point. So this is like that while loop I was talking about. So I'm using netcat. Netcat is just basically pinging 5432. If it doesn't get the response back, it's going to sleep and then call it and just continue to do that. And so my web server is not going to actually fire up until Postgres is up.
I never put it in the entry point. That's a lot cleaner.
Yeah.
You have like a separate script and it's really messy.
Yeah. I mean, I just actually in my entry point, I'm just calling it entry point.sh, but essentially you could do that same sort of thing. Yeah, you're right. And I forgot to repeat the question. I'm sorry. Next time. I'll get it next time. Okay. Any questions thus far? Any other questions? Cool. Okay. And when you have that going, you can obviously go to localhost 5002, and it's running in your browser. Okay. Nginx, reverse proxy, load balancer. Pretty straightforward. I'm not doing really anything unique there. Pulling from the base image there, Nginx, and then copying over dev.conf, and inside that conf I have this location set up, and so anytime the end user goes to /, it's getting sent to web 5000. So you know here this is not actually a real URL. Web is the container name. So when you're referencing stuff container to container, you always reference the service / container name. That's just how like the Docker containers are connected to each other. And you can spin this up, and again, this is listening on port 80. So then, if you just go to straight localhost, it should be running. Okay, so Redis. Again, nothing too interesting happening here. Inside my Docker Compose file, I have a service called web-redis. It's grabbing the image from Redis. I don't have a Docker file. This is it for Redis. And for the actual worker process, close some of this out here. The web worker process, so again, I put that in my manage.py file. So that was that run worker command. I'll show it in just a second. But this is taking the same sort of development config. So inside the development config, that's where I'm setting my URL. So hopping back out, services, web project config. So inside config, I have my base configuration, my development configuration, testing configuration, and so forth. So my Redis URL, just a straight default 6379, and then the queue I'm using is also the default too. So when I run that run worker command, it's grabbing that configuration there, and going back to web, manage.py. So it's grabbing the Redis URL, grabbing that default queue, and then if there is a job on top of that, it's just a basic first in, first out queue. So if there is a job on top of there, then the worker process will then run and process the task. One question people ask me, why don't you use Celery? Celery is complex. I don't need to use complex gives me for this type of application. Redis queue, if you haven't used it, super easy to set up, as you can tell. Just spin up Redis, pull in our queue, and then you can use a context provider to connect to it, and then you can run your jobs. You don't have all the power of Celery, so you can't you can't schedule tasks. I don't believe you can also prioritize tasks. I think there's some tools you can work on top of Redis queue for that. But if you need more power with your task queue, then yeah, I recommend Celery. Okay, worker process. So that's the web side of things. So that's all of this over here. Questions on that? Questions about how all these things connect? If you are running into issues, Docker logs is your best bet. So you'd run Docker compose -f for the name of the compose file, logs, and if you put a -f in there, it's like a tail command, so it's just going to continue to watch. This thing is definitely going in and out, but you can see all the logs here that's running inside my container. So I have Redis, my WebDB, web, and then obviously Nginx. So you can see this in real time here if you want to. So if I hit run build, you can see that in real time, all of the logs appearing there. So if you want to start debugging that, you could start putting some print statements in there and just kind of see what's happening, and then you'll get that output into the logs. I do recommend setting up the logger though. It'll definitely save you time. Down the road. Cool. All right. 8.13. That worked, or 10.13. That worked out well. So we are at a nice stopping point. So we have spun up the web side of things. And when you come back, we'll spin up the OpenFaaS side of things. We'll then look at Docker Swarm, Kubernetes, and then I have like some challenges for you all. Cool. So take a break. I guess like a 10-minute break. Come back somewhere between like 10:25 and 10:30, and definitely come up if you have questions or if you're lost. Thank you. Testing. So I'm going to wait a couple more minutes for people to get back, but there was a login screen. You are fine. So inside the manage.py file, I have this create data command. As soon as you run this command, this will add this user. You use that user because that's obviously associated with me. You can just go ahead and register on your own and use your own login if you want, or you can use that. I don't care. But yeah, if you do hit this like login like register type page, just go ahead and register. Yeah. Okay, so let's get started back up. So if you are having problems running it locally, we are getting ready to move to DigitalOcean, so it's not going to matter. So it's probably good that you fix those errors, and debugging skills are good. It's kind of like when you learn HTML and CSS and someone's like, hey, you have Bootstrap, you learned HTML and CSS for a reason. So, you debugged a little bit. So we're going to move everything to DigitalOcean as we get into orchestration. So if it doesn't work locally, it's not the end of the world. You probably will want to debug that in the future, but you will be able to move on. There was a question. There was someone interested in knowing what other sort of serverless function as service providers people use. So if you use AWS Lambda in the past, you want to quickly raise your hand? Cool. How about Microsoft Azure functions? Anyone? One person? Okay. Cool. Take a middle note there. And then Google Cloud? A few people? Awesome. Cool. Hopefully that helps. Okay. So where were we? Okay. I was hoping that break would just like my voice would just come back to normal, but nah, didn't work out. Okay. So OpenFaaS. So the API gateway, one of the things that you get from OpenFaaS is the framework. So we're not going to go over the actual API gateway. It's in Golang. If you're curious to know a little bit more about it, I can talk about it after the class. But basically what API gateway is a request comes in, it hits the API gateway, and then it routes that request to the appropriate function. Also collecting metrics via Prometheus. Prometheus is a time series data. Scaling. I feel like this is going in and out. Yeah, a few head nods. Testing, testing. Is that working? Testing. Mic check. 1, 2. Sweet. It handles scaling, and then it also provides this nice little UI for you to test out your functions. So I have my backend deployed on DigitalOcean right now. So I have these two functions, my eval function, my ping function. By the way, you should not have this deployed yet. If you already have it deployed, please come up and relieve me because of my voice. You can do the teaching. Just kidding. So with the ping command, if you click ping, I can invoke it. It sends back Pong. We'll go over these functions in just a second, but you can't see that, but there's the Pong. So that's just basic health check, basic sanity check. And again, we'll go over that in just a second. Okay, so the actual health check, let's hop in here. So the way that the functions of service work is you have a number of language runtimes already built up. The language runtime I'm using is actually called Dockerfile because I have a custom runtime going here. So inside my Dockerfile, installing Python 3, installing the requests library. We'll talk about the function watchdog here in a second. Setting the work directory as root, copying over the requirements .txt file for any dependencies, copying over my handler.py file, and eventually then just running that file. So if we look at my handler, all it's doing is printing Pong. So keep that in mind that that's really all it's doing. The eval function is a little bit more complex, but I don't have any requirements. I just kept that in the Docker file just in case I added any requirements. I could probably just take that out since I'll probably never use it. I'll talk a little bit about how that is working when we go through a little bit more of the demo of the app in terms of the OpenFaaS side. But yeah, that's really all it takes to create just a super, super basic function. So to test this out, you'll want to build this, and you probably have not already done this. This was not part of the requirements or the prerequisites. So go ahead and run this Docker build command. I'm tagging it. And I have no idea if you guys can see it, or if you all can see in back. Should I zoom in? Is that better? More? A little bigger? So Docker build -t. -t is for tagging. I'm tagging Python -ping. And then I'm setting the context. So that's in services, functions, ping. We'll see how the internet holds up here. So I am using Alpine. So Alpine, if you're familiar with sort of the Docker ecosystem, Alpine is a very lightweight operating system. So it doesn't have like everything in it that you'd say would be in Ubuntu or whatever flavor of Linux you want to use. So this is like a very stripped down version of Linux. And so this just helps to keep my Docker file or my Docker image super thin. Let's see. So hopefully we'll let this run in the background. But after it's spun up, you can then hop in. You can then run this command to actually run the container. That's the name of the image, and then ls. It's just a list, so it's just going to list the files in there. So you can just make sure, hey, handle.py requirements is in there. Then if you actually run that handler.py file with Python, you will print pong to the screen. Okay, so this is probably still running since it is installing Python. I'll just let that run in the background and move on. Okay, so the eval function, similar thing, just slightly more complex. And by the way, since we are going to be moving to DigitalOcean and relying on their network in a second, you don't necessarily need to build these images locally, so don't freak out if you can't get internet access or right now, since we will be deploying this onto DigitalOcean. So the eval service, do you all like the black background or the white background? What's easier to see? Black? Okay. Let's see. So for eval, functions eval. So I have several Docker files in here. So when I was building this, I built it in iterations. I started with just a basic sanity check, and then I actually moved on to the functionality. So if we look at Dockerfile 01, pulling from Alpine, installing some dependencies, same sort of thing, using handler.py. Handler.py is where all the magic is happening. Not sure how to make that go away. But inside my main function, I'm removing this temp directory, if it exists, and then I'm cloning down this repo. So my initial iteration of this was I'm going to hard code in the repo. I'm not going to worry about making this dynamic. I just want to get it working just so I can get a quick sanity check. So I'm cloning this down into the temp directory, opening up a subprocess, running the actual tests. Now if you see here, this temp test.py, that's coming from that PyCon sample. If you remember, the test.py file is in there. So you have to have that test.py file there. This function is not smart enough to know, like, hey, where's the test.py file? Which version of Python? What dependencies do I need? So this works. This is just the bare minimum to be able to run the tests and be able to have some sort of functionality on the client side. So then I'm getting the standard out or standard error. Based on that, I'm going to be printing something to the screen. And the way that these functions are working, they work with the standard in, or I'm sorry, with the standard out, actually standard in too. And that's with that function watchdog. I will talk about that here in a second. But I'm grabbing either standard out, standard error, and then grabbing the value of the standard out here, and then just outputting that to the screen. So when the tests fail, it's going to get printed. Test pass, it's going to get printed as well. Handler 2, similar sort of thing, only I'm working with standard in. So I'm getting the standard in. Consider that just like your JSON payload, your request object. That's kind of like, in this case, that's how I kind of treat it. So I firing this function gets standard in, so it's getting the standard in. Destringifying it with JSON loads, grabbing that namespace, so test-driven IO, grabbing the repo name, so PyCon sample, using fstring here for getting the URL, if kind of handling errors. It's not very robust, but there is a bit of error handling here. Again, instead of making this a little bit more dynamic, instead of just adding it to the temp directory, I'm using temp directory repo name. So it's going to clone it down to that directory. So I'm removing that directory if it exists, running the tests, blah, blah, blah. So very similar to what was happening before, only it's more dynamic. It takes a namespace and a repo name, so it can be run against any repo in theory, as long as it has that test.py file. I then am sending back, I'm stringifying this dictionary here, and sending back a status code. So it's either true if the tests pass, false if they fail, and then grabbing the standard out. So that's the logic that I'm using on the client side to display pass or fail, and then adding the results of the tests to that terminal thing. Inside requirements, I'm using get Python. That's just a nice little wrapper for the GitHub API. So I can use this syntax here, repo.clone from URL, to actually do the cloning. Questions? Okay, so since I did do multiple iterations of this, I do have my V1 here. V1 is using Dockerfile 01. If you were to test it out and call handler.py, that's just going to work against that one repo, and then when I ran it at that time, the tests were passing, so you would get either the test passing or failing. Eval v2 is the one that is a little bit more dynamic. It takes the namespace and the project. And so for this one, so yeah, here's where Watchdog comes into play. So that's a tiny little HTTP or like web server that's bundled with each function, so that handles, so that gets the HTTP request from the API gateway, manages the triggering of the function, and then grabs the standard in, and then sends back the standard out. So if you are going to be using this for HTTP requests, I think a standard in is just a basic, JSON payload. Standard out is your JSON response coming back. Questions on that? So that's another thing OpenFaaS gives you. It gives you the API gateway, and it gives you that function watchdog. People have asked me, why you could just recreate this on your own. You could, but you'd have to add that API gateway function, the function watchdog, Prometheus. There's all kinds of like scaling logic built in there too. So there is an actual framework built in there. Curious if this is done. So that's done. I'll skip the actual testing of it locally so we can move to deployment. So questions on OpenFaaS. I know like you don't have all the context right now of how it's working, but you should have like the basic gist of like, yeah, there's a couple functions there. API gateway, we're sending the request from the worker process to that API gateway. That API gateway is then routing it to the appropriate function. No, there's different scaling rules. So the question was about is it always like a one-to-one relationship between functions and containers? There's different scaling rules. We're going to be just using one node or one container right now, and so everything is going to be in that individual container. But using Docker Swarm or Kubernetes, you can spin up like worker containers and connect them, and then you can scale your functions there as well. So there's different ways of scaling. Any other questions? Yeah. Okay, so the question is about if you fire that function again, do you have to start up Python again? I would say no to that because we are installing Python inside of the Docker file. So it should be up. Maybe your question is more around like, okay, if you spin up a new container, like does it have to spin up Python at that point?
No, I was looking at the main function like this right now, and we clone the repository, but then when the test executes, we just exit the final process.
Oh yeah, yeah.
If we want to run the tests again, we have to fire up a new one.
Yeah, you'll have to spin up that new sub process again.
So how does that influence like the latency?
Yeah, will definitely have to take that into account. So the question is more about latency, about going back to the eval function here inside my handler.py file. So I am opening up the sub process here, and it does get closed out. So you could, I guess could manage that in a different way. You might not actually need to use a sub process here. There's probably a way that you could run these tests maybe outside of a sub process. Um, Mine's kind of going blank right now on what that would actually look like. Yeah, maybe if you want to connect to me or connect with me like when we're done. Like I don't have an actual like solid answers to that, so I need to like think about that. If anyone else has any solutions on that, like we're spinning up basically a new sub process, each time we run this function. Could we, maintain that sub process somehow? Could connect to it. I guess we could save the process, ID. The problem with that is then you're kind of maintaining state, and how is that new function going to get that process ID? You could send the process ID back with you, then maybe like reconnect with it. I think there's multiple things you could do there if that becomes an issue, but I can't think of really a solid, answer to that right now. But yeah, give me some time to think about that. Great question. Any other questions? Yeah, you'd also have to make sure you're on the same container too. It's like if you have that function spread across two containers and a subprocess in one, and then you kick off a job in here and press the process ID there, it's not going to have any idea what's going on there. So you'd have to take that into account too. Okay, deployment. So container orchestration. So as you're kind of like moving from, say, deploying an application across a single container, and you want to scale that across, multiple machines, maybe you have a load balancer in front of it and route traffic appropriately. That load balancer needs to be aware of where these containers are. Which containers do I have up? So you have to take into account, service discovery. So container orchestration is just an orchestration tool to manage the arrangement, coordination, and availability of the containers across the entire system. So this is where Kubernetes and Docker Swarm mode fit in. There's also a number of other tools out there. I've used ECS in the past. That's AWS's solution. Elastic Container Service, Mesos. Nomad is escaping on that company. HashiCorp. HashiCorp is behind like Terraform templates and Vault and Console for holding secrets and stuff like that. So if you're kind of like maybe already using some HashiCorp type products, you might want to look at Nomad. I feel like the big one is Kubernetes. Docker Swarm is pretty popular as well, and ECS is there as well in terms of popularity. So which one? Kubernetes probably by far the most popular at this point. Large community, super flexible, has the most features, is pretty complex to set up. Docker Swarm mode, easy setup, easy to get going. You are like limited to the Docker API since it's built in the Docker. ECS, in my opinion at least, is the easiest setup. It's integrated with AWS. AWS is already your thing, and you don't plan on getting off of it, then maybe you could look at ECS. There is a number of Kubernetes sort of as a service out there. I think there's EKS. I could be wrong on that, like the actual abbreviation, Elastic Kubernetes Service. And there is DigitalOcean is getting ready to spin one up as well. Google has one as well. I don't believe there are really any Docker Swarm as a services out there besides maybe Docker actually has a service behind the scenes. I'm not sure actually how Docker makes money. If they make money, I feel like they make money, but yeah. So depending on what you're doing, a little toy app. If it were me, I would probably go with Docker Swarm. Something a little bit bigger, I would probably go with ECS. If you really want to dive into things and get your hands dirty, then go with Kubernetes. I do have this comparison blog post there. It goes really in depth on a number of these. In terms of like a feature wish list with your container orchestration, you want health checks. You want to make sure, is that service up? So as a new service gets spun up, kind of like if it's an HTTP service, maybe you want to ping it and get back a 200 response. Maybe you ping it, not only get a 200, but you also check to make sure Pong comes back or whatever it is. So you want something there to be monitoring it to make sure, is this actually available and up, or actually available and working before I route my traffic there. Dynamic port mapping. This was a big one with ECS. You weren't able to do that until the application load balancer was added to ECS. So basically, you want to be able to, if you think of those ports on the right side and the left side, you want to be able to dynamically generate that port on the left side. So if you're spinning up 5 Flask instances, they all can't be running on port 5001. You want the load balancer, the service, the orchestration tool there to assign an available IP to it. And so on ECS, you weren't able to do that before the application load balancer was a thing. Zero downtime deployments, or the blue-green deployments, you want to be able to spin up new containers before you spin down containers and route traffic appropriately so users don't have downtime. You also have to take into account, like if you spin down a service and you have users on that service, how do you make it easy for them to transition to that new container? So if you think of like the CI as a service, so if I'm running my my build on one container and that container gets spun down, and then you route traffic to that new container, that's going to be like a jolt for the end user. So you kind of maybe have to have like a deploy window or something like that when there's probably very, very few people that could be using that service. Service discovery for spinning up new containers and whatnot. Auto scaling and being able to spin up and down resources based on the load. Provisioning, being able to provision those boxes, those EC2 instances, droplets, whatever it is, to be able to run Docker and whatever else you need. I'm definitely missing a few, obviously load balancing, logging across components, or that should actually be containers. Logging across containers is obviously a big one. You want to be able to aggregate your logs, be able to grep it pretty easily. That's another thing with AWS. AWS, you could do that with CloudWatch. It becomes very difficult then to grep them from the AWS. Or you can't grep them from the AWS GUI, so then you kind of have to like maybe pull them out from CloudWatch and grep it locally, or like you'd have to you could SSH into that box and then get into the Docker container and view the logs there. That's not scalable if you have 50, 100 containers. You obviously want to be able to aggregate those logs somehow. Then monitoring kind of goes hand in hand with health checks. I don't know, am I missing anything else? Perfect. Okay, so DigitalOcean setup. Who doesn't have a DigitalOcean account? Awesome. You guys all get $100 in credit. So I'm going to disconnect for just a second. I'm going to grab this coupon code really quick because I got to hop into my email. I want you all to see my juicy emails. The only person that really emails me is Frank, so it definitely gets pretty juicy. Okay. Okay, so URL do.co/PyCon 40. So this will only, I believe this only works for new accounts. So if you already have an account, you may want to set up a new account just for this. And I think you will still have to put in a credit card. Does anyone need help? Anyone have questions about this? You don't have to use the credit for this. I think there's like 60 days to use the credit. You can use it for wherever you want. I don't work for DigitalOcean. Does anyone work for DigitalOcean in here? Okay. No, DigitalOcean is great. I use them for almost everything that I'm spinning up. So what do you think, like 5 minutes? 30 minutes? An hour? Let's go with 5 minutes. So what, it's 11:05, or it's 11, so let's go to 11:05. When does this thing supposed to end? 12:20? Is this not working forever? Is it? Oh, it's working? Okay. Yeah, if you already have an account, maybe think about logging or signing up with a new email address just so you can use it. You have a question? I'm sorry? Oh, okay. You can use Bitcoin. I'll hold you to that. Yeah, you don't have to sign up for an account. No one's making you sign up for an account. I'm not going to come twist your arm or anything. So if you don't want to deploy this, like you just want to watch, like that's totally fine too. I would still take the $100, but you guys can. You already have an account. Anyone need help? Questions? Wait a few more minutes. Move on. Wait a few more minutes. Okay. So I always feel like during these talks, there's always like one or two people that I consider like the spokesperson for the entire class. And it kind of like always reminds me of like when I'm out to dinner, like with a group of people, there's always like one spokesperson for the table where that the waiter or waitress will always go to that person and be like, "Are you okay?" And usually that person is oblivious of what's really happening at the table. I could like gut open my stomach and be bleeding out on the table. And as long as that spokesperson says that I'm okay, it's okay. Little joke. I'll shut this off.
Scaling and like not being constricted by like lambda constraints.
So while we're still waiting, I kind of like when I was going over the cloud computing models, because kind of bringing up like you have to weigh the costs and benefits of doing things, how much control you want. So the question is like, what are the actual benefits that you get from OpenFaaS? Is it going to be cheaper than Lambda? Probably not at first because you are, having to spin up containers. It's more of a container as a service type solution um, than a function as a service type solution. But yeah, you will have to probably pay a little bit more upfront. You have more control over it, obviously, because you have control over the underlying infrastructure. You have like the language runtime type constraints with AWS Lambda that you won't have with OpenFaaS. It's really just the control aspect. It will be a little more expensive upfront. Scaling, as soon as your application scales on Lambda, and Frank is actually a good person to talk about that. But like the costs associated with that, like it may not be cheaper. It just at a point it's probably going to become cheaper just to run something all the time because the compute processing with the AWS Lambda can get expensive as you scale. Probably run like a 4-hour workshop just on managing that and the logic around AWS Lambda.
Everything on AWS is certain point hockey sticks. OpenFaaS represents a finite operational cost. You have, if you can manage that scaling issue in terms of pricing.
So it's more linear
Yeah.
because you're spinning up more Kubernetes workers as opposed to hitting the curve on with the pricing.
So along with just signing up, go ahead and generate a personal access token. Um, just just so I'm aware, how many people are actually continuing on with DigitalOcean? Okay, so about half. Sweet. All right, so go ahead and generate a personal access token. Um, there's a little bit of information about how to do that there. I'll actually show how to do this. What is that? Let's see. Is it under settings? Is it API? Okay. Okay. So yeah, you'll just want to generate a new personal access token and then set it as an environment variable. So generate new token, token name, PyCon 2018, generate token, copy it, and then just go ahead and set it as an environment variable. So this is obviously Unix centric, but you can do export And you don't have to name it digital access token. You can name it whatever, but so just do digital access token equals the token. Yes, I am exposing my token. If somebody actually does copy that down, like, more power to them. Like, someone will actually do it now that I brought that up. Okay, all right, I'm going to move on. So let's start with the web app. So Nginx, Flask, Python, Redis, worker process, Postgres. We're just going to use Docker machine for this. I'm not going to get into the container orchestration side for the web app. We're just going to use Docker machine. So if you run this command here, this Docker machine create, you can pass in this flag of -- driver. So the driver is for the backend, for the machine backend. So there's multiple drivers available to you. So on the Mac side of things, you have a VirtualBox, so you could use a VirtualBox backend. There's also EC2, DigitalOcean. There's probably a few more. I can't think of them offhand, but this will spin up an instance on DigitalOcean, and it will provision the machine for you to run the latest version of Docker. So what am I doing here? So I'm creating that machine on DigitalOcean. It does need that access token because it's interacting with the DigitalOcean API. And so you could hard code it, the access token in there, but since we're going to be using it multiple times, I'm just referencing that environment variable. I'm calling the machine web. So I'm going to run this command. So this will spin up that new droplet on DigitalOcean. If you go to your DigitalOcean dashboard, you can see it's already starting to spin up. So there's some default, settings with this. It selects it looks like a droplet in New York City, 25 gig of disk space, 1 gig of memory. There's flags to change that as well. We're just going to use the default for now. So while this is going, any questions? I should have pre-spun this up so you wouldn't have to sit here waiting. Or save that awesome joke till now, because that was like the one joke. I said that in the mirror like 50 times last night. I didn't, but it is a default joke that I go to a lot, and Frank just pointed out it's pretty morbid, so I apologize. Some of you were like, "What joke?" This should take like 10 to 20 more seconds. Cool. So now our Docker client, we want to point that at that machine backend. So we run this command, docker machine env web. Along with this eval command. So now when you run our Docker commands, it's running against that machine on DigitalOcean. So at this point, I just want to run this command again and run this on DigitalOcean. So this should be lightning fast since we're not using the network here. This is running on DigitalOcean. So downloading Postgres. So it's building the WebDB now. Now it's building the web, so it's pulling from Python 365. So it'll take a little bit to install that. While it's going, any questions? So when that's done running, you want to grab the IP address that's associated with that machine or that droplet. You can either get it from running this command docker machine IP web, or you can go directly to the DigitalOcean dashboard, copy it there. And as soon as that's up, so let's see what it's doing now. So it's still, looks like it's still building my web image. Okay, yeah, it's downloading like the dependencies here that I need. Once that's spun up, again, just like you did locally, create the database. You don't need to run this create admin command. You can go ahead and run this create data command, and then you should be able to log in at that point. You can also run the tests. If for whatever reason you get an error, or like it's not showing anything when you go to the IP address in your browser of choice, run the logs command. Take a look at what's going on in those containers. That's your best place to start debugging. Okay, so I moved on to Nginx, finished Nginx. Now it's doing Redis. Okay, so everything should be spun up at this point. If I refresh this, I get this 502 bad gateway. All right, so what is happening here? I think it's probably an issue with the fact that I haven't ran my migrations. So let me run this command. So that was it. It worked. I was holding my breath up here, but we got it. At this point, I'm going to run my create data command. So now I should be able to log in as Michael at mherman.org, and my password is Herman. I should be able to log in. So the web app is up at this point, at least on my side. I can add a project, remove a project. If I run the build right now, it should just sit there spinning because we don't have OpenFaaS up right now. This is passing because I am using the URL. The URL was hard-coded from the OpenFaaS network I've spun up. So you won't need to do this on your side. But for the demo earlier, I had this spun up already. Let me bring it down. It should spin now. Yeah, so. Questions on that? So getting a basic application on DigitalOcean with Docker is pretty simple. Maybe not simple, but it's a lot easier than like popping a container orchestration framework or tool on top of there. Really, you can just use leverage Docker machine. Now, again, this is only running on a single node right now. There's multiple containers running in that node, so its scaling is obviously very difficult at this point. But if you just want to get a toy up really quick, just get a quick sanity check, whatever it is, this is a good way to do it. Any questions? Anyone lost? A couple people lost? Just, blue shirt, beard. Anyone else lost? Cool. Okay, I'm going to wait a couple minutes before we dive into OpenFaaS. Out of curiosity, how many people have been to a tutorial at DockerCon or at PyCon before? Is it generally, I'm curious, is it generally more hands-on, or is this like kind of how they go? Depends. Okay. We're going to get into some more hands-on stuff, so. A lot of, like, I think this is the first conference that I've been to where I've pitched a tutorial where people actually know it's a tutorial and they bring their laptops and they expect to like code along. A lot of time, like at PyTennessee, I did a very similar talk and it was pitched as a tutorial, but it was kind of like just fine print on like the program like schedule. And some people showed up and they're like, some people didn't have their laptops, and so it was just like managing those expectations were just very difficult. It's like, well, can't really do much there. You could have mine, but then I can't present. But so it's I like the way that PyCon actually does it. They actually separate out the tutorials from like the main talks. Okay. Oh, cool. Yeah, I did put out those handouts too, so I'm glad that was actually. I was paranoid they weren't like, because no one contacted me in the first like day or something like that, and I was paranoid that people weren't actually getting those emails. But then I got a couple people that were like, "Hey, what's Docker?" That sort of thing. I'm like, I don't know. I'm learning it right now. Okay, so moving along, let's move on to OpenFaaS. So we're going to be spinning up the API gateway, the code eval, and the ping, or the sanity check. So I'm going to start with Docker Swarm mode. At that point, we're going to we could go into Kubernetes, or we could go into some challenges if you want. So we're going to start with Docker Swarm mode, since this is like the easiest way of doing it. Get it up, test it out, make sure the full thing works, and then we can always spin it down and spin it back up with Kubernetes. Okay, so very similar thing here. We're going to start with creating a new machine. So exact same command. I'm just going to name this machine something different, calling it OpenFaaS. So this will take a few seconds to spin up. Oops. There it goes. Not sure why I have two webs right now. Maybe I hit the Docker create command twice. I don't know. So a droplet is spinning up right now, and so it's going to install Docker and everything on it. Anyone else stuck? So this command here might not be exactly right. If you run this command, docker machine env openfaaS, it will display the right command for this. So this, I'll show you in just a second. So docker machine env openfaaS, at the very bottom here, it'll tell you the exact command to run. So there was someone on a Mac that had like a different syntax for that command using the exact same version of Docker. I don't know what's going on anymore. It's probably different on Windows too. Okay, so after that spins up, you want to point your Docker daemon at it. So now it's pointed at that new Docker machine. Do you want me to pause for a minute? Anyone else lost? Need help? Okay, I'm going to take silences like we're all good. We're all great. Okay. All right, so after that, I want to initialize Docker swarm mode. So I'm going to run this command, SSH, into that OpenFaaS box. Now that I'm thinking about it, we probably don't actually need to do that since we pointed the Docker daemon at it. But we can do it anyway. So this will initialize Docker Swarm on that initial node or that initial container. It's treating this node as sort of the master or manager. I can add worker nodes and connect them at this point if I wanted to. I'm going to simplify this and just say, hey, we want to run our entire Docker Swarm stack cluster, whatever it is, on this single node. If you're doing this in production, you would obviously want to connect workers to this. But what you would do at that point, spin up a new machine and then run this command on that machine. This is basically a token here that will link that specific machine to the master, and so that it's aware of it, so that when you do need to spin up multiple instances of things, it will handle putting it on different machines. So, okay. So we created a new machine, pointed our Docker client at it, and then initialize swarm mode. At this point, we're going to go ahead and build our images. So I'm going to start with, would it help if I move this over here and this here, or can you not see it at all? Anyone in back have any preference? This is like, can we see this at all? So I see one yes and like one half no. No, there's a big no. Okay, all right. Yeah. Let me see if I can. Of course, I can't zoom in there. What the heck? Like that? Any better? I don't know why I can't zoom in on this stuff here. Okay. So, yeah, you want to build your images. If you're having trouble seeing this, the URL you've put it's /pound92. I'm on slide 92 right now. So if you're having trouble seeing this, pull up the slides locally on your machine. So apparently I can't zoom in on this. I could drag this closer, but I don't know if it's gonna help. Okay. So I'm going to build my ping or my sanity check command. Again, this is building up on DigitalOcean on the machine up there. That's why it's going so fast. It's not all of a sudden the PyCon internet just got super fast. Not sure why I thought that was funny. Okay, so that installed, or that spun up, built those images. Now we want to deploy OpenFaaS. So to do that, run this command here, docker stack deploy. is for deploying a Swarm cluster. I'm calling it func for functions. I am using a compose file for this. You can also use a just gave me stack file, I think is it's what it's called. Is that right? Stack file? Possibly close. Okay. All right. So I'm using that Docker compose file, docker-compose-faaS .yaml. So while this is spinning up OpenFaaS, let's take a look at this compose file. So inside my compose file, I don't know why I was zooming out there, sorry. So we take a look at my services. So for services, you see the API gateway there. FaaS Swarm is another tool that comes from OpenFaaS. This allows you to, OpenFaaS. Sorry, it allows OpenFaaS to be deployed with Docker Swarm. Then you can see my eval and my ping functions there. Not going to dive too much into the gateway and FaaS Swarm. I will note that I am using OpenFaaS in a way right now that is different than sort of the intended use of OpenFaaS. So I'm kind of like, I have more, again, going down to that question about why would you want to use OpenFaaS? I have more control over it. So I'm actually using OpenFaaS in a custom way here. You can literally use OpenFaaS without using the gateway and FaaS Swarm. What you'd need to do at that point is clone down the FaaS repo, and then you can run a command against that to spin up those functions. So I'm doing something particular with my API gateway that I don't get out of the box with OpenFaaS, and don't know if that's making much sense, but it's basically using a custom version of OpenFaaS that I cloned down, I forked, I changed a few things. I will show you actually how to use OpenFaaS its intended way when we spin it up with Kubernetes. Let's see. So in terms of, there are a number of environment variables here. Some of them are straightforward, some of them very esoteric. You know, the read timeout, the write timeout, upstream timeout. So I don't know what all these mean, but I'm guessing the read timeout is it just maybe has that long to. Some of this probably is related back to like how long it takes to run the function. So going back to 300 seconds, this is like defaulting like 25, 25, and 20. I don't know exactly how these relate back to that, but if you want to customize that, you can. Not sure what these actually are. So a lot of this is coming out of or all of this here, I didn't touch. It comes out of the box with OpenFaaS. Memory reservation. Actually, here's the window for, that's actually the restart policy. So restart policy condition, if a function fails, it's going to restart it. There's a 5-second delay, max attempts. So it'll just continue to try 20 times to spin up something new. And then I'm not sure exactly what the window is for. I'd have to look at the documentation. Placement constraints, this is for where it's going to place this service in relation to Docker Swarm. So it's only going to place it on a node that has Linux on it. Again, I'm not going to really go too much into Docker Swarm because this stuff you get out of the box with OpenFaaS. So the things that you really want to worry about are the eval and the ping. So the eval takes an image for OpenFaaS to know that it's a function. I have a label there. I did specify a network for the functions, environments. These things come straight. I copied and pasted this from a straight regular function. I can't tell you what they do right out of the box. I'd have to look at the documentation. Again, with the deploy constraints, setting that to a Linux box. Same exact thing for the ping. So if you want to spin up, like, say, like a new function, literally you could just copy and paste this, and the only thing that you would actually need to change there is the image, which we will actually do here in a bit. So you can see here when I ran that docker stack deploy func command, you can see the network that was created. So I called that functions. It's getting prefixed with the name of the stack here. And then you can see the ping function, the eval function, the gateway and then the gateway service and the fast swarm service. So at this point, all net is spun up. It's ready to go. If I head back out to the presentation here. So I'm going to grab this IP address. So this is where this is living. It's going to be on port 8080. And so that's the UI there. Sorry. And so you get that UI from the API gateway. Okay, I went over a lot there. Probably a lot of questions.
Are you going to demo how to lock down OpenFaaS?
If we get to it, if we have time. It's kind of like, the question was, am I going to show how to lock down OpenFaaS? So you can pop Nginx in front of there and lock it down however you see fit. You can expose only certain ports. You can put a load balancer in front of there too. It's kind of like a stretch goal that I have. Like I can show, there's an awesome blog post that shows, that I can reference that shows how to do that. But if we have time, I can show how to do that. Yeah, you definitely want to actually lock this down if you are using this in production. Good question. Any more questions? Okay. Yeah.
You mentioned you could have different scale policies on OpenFaaS. Where would you set that?
I'm going to get to that in terms of scaling, yeah. Any other questions? Sorry, the question was on scaling. Am I going to get, I'm going to be showing scaling in a minute. Sorry, I keep forgetting to repeat the question. Any more questions? Anyone lost? Okay. All right, so going back. So to test this out, you can run this straight curl command. In here, I'm basically just grabbing the IP address for OpenFaaS and echoing that and then using that in front of 8080. You could do that, or you could grab the actual IP address from OpenFaaS here. This syntax will probably differ if you're on a Windows machine. Actually, I mean, if you're probably using like some sort of Linux emulator, right, on Windows? So it might be the same, might not. So you can run this. Don't run the Pong. The Pong is the actual output. So just run this. You should see the Pong. You can also run this on the UI here. Got my Pong. I'm going to run this eval. Remember, this is using version 1 of the eval, so everything is hard-coded in there, so it actually doesn't need the namespace and the project name. So I can just invoke this, and I should see the tests passing. If I go in here, change this, you can see the tests are now failing. So it looks like everything is spun up right in terms of OpenFaaS. Yes, you probably want to go ahead and test that out. The UI is available on that port, 8080. And so moving on, I'm going to build version 2 of this. And again, I'm just tagging this. If you're familiar with Docker tags, I'm tagging this just with latest. You could tag it with v1 and v2. If you were going to do that, you would want to change it right here. Instead of pulling from latest, you would want to pull from either v1 or v2. Okay. So that should go super quick because of the caching. A lot of those images or a lot of the layers are going to be the same from when I ran V1. So it's just using, you can see here, it's using the cache in a lot of the instances. So redeploying, I'm actually bringing the stack down to redeploy and then deploy and then actually redeploy it. I'm doing that because I found when I just ran this command, it's using OpenFaaS underneath the scenes is using some sort of caching. I couldn't figure out how to break the cache there. So this is kind of a bit hacky here, but I'm going to bring down that entire stack, and then I'm going to redeploy that stack. And it will, there's a race condition there. Part of it's down, part of it's still up. So now it's going, but there's an error a second ago. So if I go back to my UI, should be the same. The eval function should break at this point because it takes the payload now, because it needs to take the namespace and the project name. That's no longer hard-coded. So I invoke that, I get an internal server error, I get an awesome little error message there. Please provide a repo name and a namespace in the payload. And so we'll actually need to hit it with, you could actually, you could do this in the UI here by just changing this to JSON and saying names, I think namespace is one word, and then test driven IO. PyCon -sample. So now you can invoke it. And you can see that I am actually getting back the appropriate response, false, 22 does not equal 23. You can also run this with curl, or test it with curl, which is what I'm doing in the presentation here. Questions? Who's lost? Okay.
How does OpenFaaS know which functions are available?
So that's a good question. I think I've said that for every question. Every question is good. How does OpenFaaS know which functions are available? How does it know how to route traffic? So that's a combination of the API gateway and that function watchdog. API gateway handles the scaling, and the function watchdog is taking the request from the function watchdog runs at the individual function level, but that was what handles the request that gets sent from the API gateway. So sort of a combination of both, probably more of just the API gateway. Any more questions? Cool. So now, the big finish here, we want to be able to click run build. We want that to get added to the task queue. We want the worker process to pick it off the task queue. We want the worker process then to be able to hit OpenFaaS. So right now the web app and OpenFaaS are not communicating with one another. And they communicate just over just REST. So I'll show you where to configure this. So inside my Docker Compose web prod, OpenFaaS URL. So you want to just grab the actual URL. Put this in here as environment variable. Then you'll just want to rebuild that. So now to do this, remember, I am on the OpenFaaS machine right now. I need to switch back over to the web machine. So you can tell which machine you're on by saying Docker machine ls. You can see the active machine is my OpenFaaS machine. So I need to go back to my web machine. So if I say Docker machine env web, this will give me the right command here. So eval Docker machine env web. So now when I redeploy, it's going to actually redeploy it on the right machine. So I can run Docker compose. Let me just go through my history here. So by running this command, this will redeploy it, pop the correct environment variable into the container, and then the container then, when we run the run build command, it should eventually send the post request to OpenFaaS. So I'll rebuild this. Should be lightning fast. Okay, and if I go back, let me just refresh this. So let me run the build now. So you can see that it is hitting the OpenFaaS backend now. Change the status. If I go in, change this back to 22. Commit changes. Run the build again. Test pass. So everything's wired up. Web app is deployed with using combination of Docker Compose and Docker Machine. The OpenFaaS backend is deployed a combination of Docker Machine and Docker Swarm mode. Everything looks like it's communicating and wired up correctly. If we want to run the tests, you would just run the name of the service, which is web, and then Python manage.py. Let's run the test with coverage. Let's see what our coverage is. So we're at 32%, not looking so hot there. Let the tests work. We can also run, I think it's Flake. Let's make sure I'm following PEP 8, and I'm not following PEP 8. So a couple dependencies, a couple things I'm importing that I don't need. This build command, it's undefined. But these commands are getting run against that live container up on DigitalOcean. Okay, any questions? Yeah, so the question is the web application deployed separately from OpenFaaS? And yes, they are deployed completely separate right now. So how do you decide which code runs in OpenFaaS and which doesn't? So if I'm understanding your question correctly, that's a combination of pointing to the right Docker machine backend. So there's two Docker machines right now. I'm using, I pull this up. So inside my Docker machine ls is listing all my machines. I have OpenFaaS and web. Right now web is the active machine. So whatever Docker commands I run right now are going to run against my web app. If I want to switch over to OpenFaaS, I would just run that command docker machine m OpenFaaS and then run that eval command afterwards. And I'd switch over to OpenFaaS. And so then any Docker commands I run there would run against OpenFaaS. Yeah, so the question I guess is more around how do you decide as a developer when should I put my code in my web app, when should I put my code in OpenFaaS? Is that okay? And that that's obviously up to the developer. OpenFaaS is good for certain things. It's like if you think in functions as a service or serverless are good for certain things, trigger action type thing. So it's good for handling HTTP requests. It's good for running sort of one-off things, background processes, that sort of thing. I've heard of people like replacing like a message bus for a microservice stack with all OpenFaaS type functions. So it really, it obviously depends on, the developer and like where they want to put like that logic. But it's good for certain things. It's not good for other things. I would say a lot of Chris here does a lot of like data processing, big data stuff, and he may say otherwise. But I would say OpenFaaS is probably not a good place for that. I have seen blog posts that will like deploy like a Spark cluster up with AWS Lambda, and I think that is crazy. But I mean, people are actually doing it, so it just really depends on kind of what you're doing. And like if you Google like say like serverless use cases or AWS Lambda use cases, you'll get like the same sort of thing of like trigger type action, HTTP requests, cron like jobs, that sort of thing. Any sort of like background processes you want to keep outside of your web app, anything that could potentially tie up the the request handler from sending back a response, you can just pop that into a task queue and then have your Lambda or have your function as a service like actually process that. Cool. Any other questions? Awesome. All right, so it's 11:49 and 12, so we have what, half an hour. So we can go one of two directions. I do have steps here on deploying this with Kubernetes. Honestly, it's a similar process. It's a more complex process. It's going to do the exact same thing with Docker Swarm. So we can pull down the Docker container, or I mean the Swarm cluster, and then spin it back up with Kubernetes. We could do that, or we could jump right to the challenges. So the challenges dive a little bit more into Python, a little bit more into running your own functions. I would say I think the challenges would personally be more interesting. If I am happy to stay like all day, I love talking about this stuff. So 12:20 hits, you guys don't have to leave. I'll still be here. I'll still be coding probably. So we can go over Kubernetes then if you're interested in then. But I would say the challenges are going to be more interactive too. So what do we think? Who wants to go over Kubernetes? Sorry. Who wants to go over challenges? Cool. All right. Like I said, I'm happy. Like all the steps are literally right here to deploy this with Kubernetes. Granted, like I don't go deep into like the different pieces of the Kubernetes, but you can follow. It's pretty straightforward to follow along. But yeah, I'm happy to go over this, especially if we have time after the challenges too. Okay, so for the challenges, if you think of Travis CI and you go to Travis CI, Travis CI runs, or like Travis CI, Circle CI, Jenkins, whatever it is, it runs when you push code to GitHub, right? So right now we have to manually trigger that build from the from right here. So the first challenge is going to be to add a webhook in there. So inside of GitHub, you can add a webhook either at an organization level or a project level. So probably better to do it at a project level. So basically, you can set that up based on certain events, and I'll go over this in a second. But what we want to do is we want to send a basic post request on using a webhook anytime we push code to GitHub. That post request then will hit an OpenFaaS function. That OpenFaaS function will then clone down the repo and run the tests, and then from there it's going to send the results to our web app. Our web app then will communicate with Postgres and update Postgres. Now you could have the function connect to Postgres as well if you wanted to. That there could be an issue with, like, if this thing happens to scale out with managing the database connections there. That could become an issue. You have to manage that yourself. So I would just let my web app do it. Just send it to your web app and then let SQL Alchemy handle all that stuff. So you may not be able to see this in back, but pull it up on your screen. So end user pushes code to GitHub. GitHub then will trigger that webhook. Webhook will then send the post request to our API gateway. We're going to set up a new function called hook. Hook is going to run our tests. We're going to send that back to our web app, so that's going to hit our Nginx. Our web app, we're going to have to set up a new view or request handler, and then that will update our database. So these are roughly the steps you want to go to. So deploy OpenFaaS. We've already done that, obviously, so that's up there. So we want to create a new function. I put that in here for this could be a good use case for an async function. Right now we're calling functions synchronously with OpenFaaS. You can call them asynchronously as well. I'm not going to go over that, but there is a link there with that. So we're going to create that new hook function. We're going to add that function to our Docker Compose file. We'll set up our GitHub webhook. We'll do a quick sanity check. Then we'll update the function with the actual intended functionality. We'll test it again. We'll deploy our OpenFaaS back, or we'll deploy, sorry, our web app, which we've already done. We'll add that new route handler in. We may need to update the function again, and we'll do one final test. So when I was actually building this out, these are the steps I went through. So do you want me to code this along live and do like sort of like an interactive thing, like what should I do next, that sort of thing? Do you guys want to, or do you all want to take a shot at it and like do it on your own with, you know, your best friend next to you? You can get in groups. This is something that Chris will definitely be able to help out a little more with. Not that he hasn't been help. Sorry to throw you out there, but he's really good with Python. So we're getting into, you know, the Python world a little bit more. Live demo. Who wants me to do it live and you guys watch? Who wants to do it on their own? Oh, you guys are doing it, or you all are doing it on your own. Just kidding. I keep correcting myself with like all this. There's a lot of stuff going on Twitter right now with you can't say you guys anymore, and like I'm from the Midwest and like that's my thing, and so I'm like constantly correcting myself with you all, so that's why I'm saying like you guys then you all. I'm constantly correcting myself, so bear with me. I'm getting there. Okay. All right. So deploying OpenFaaS. We've already done that, so let's go ahead and create a new function. So what I'm going to do here is go into my Docker Compose file here for my function as service. I'm just going to copy this ping command, or this ping function, sorry. I'm going to rename it hook. So now I'm not going to change anything else on there. Oh yeah. Is that good? No. I'm basically just copy and paste job at this point. So now we actually need to set up that new function inside of here. So I'm going to start with, let's just copy the eval here. Duplicate that, call it hook. Let's see what's going on inside of here. So inside, let me simplify this. So I'm going to remove those two Docker files. I'm going to remove my handler2 file. My requirements, I'm going to leave that the same. Inside my Docker file, let's see what's going on here. So it's referencing handler2. So I'm going to change that to handler1, just handler. And then inside of my handler, let's see what's going on here. So really at this point, I want to get a quick sanity check. All I care about is, one, this function is wired up correctly, and when I do my webhook, which we're going to set up in a second, I want some sort of response to come back from this function that indicates, hey, that it worked correctly. And so all I really want to do is basically just send back what it's sending me inside of the post request. So I'm going to leave my standard out IO there. Actually, I should have saved to my handler 2 because that has my get standard in function here. So I'm actually going to copy this. I don't know if people are coding along. I can go a little bit slower, but basically I'm just going back to my eval, grabbing my handler2.py, copying everything in there, and pasting this into my handler.py file. So this will give me the function I have here for just getting the standard in, just as I don't feel like typing that all out, and I don't remember what was in there to be honest. But so let's simplify this so that all it does is just returns what's getting sent in from the post request. How would I do that? So we want to definitely keep this line. So this line is doing JSON.loads, it's getting the standard in, firing standard in, and then assuming that it's JSON, which is what is going to be coming in from the webhook. I want to de-stringify it and then assign it to that variable. So really, I'm just going to eliminate all this for now. So I don't know why this is screaming at me right now, but might have too much running on my computer right now. So right now, inside the main function, all I'm doing is just grabbing that payload, and then grabbing the standard in, de-stringifying it, re-stringifying it, and then printing it basically. You could probably eliminate the JSON.loads at this point and just get the standard in and print it back out. We're going to end up having to use JSON.loads here in a little bit, so I'm just going to leave it there for now. But all this is doing is just grabbing the standard in and sending it back. So that way, when I send the post request from the webhook, I'm going to be able to get back exactly what I'm sending it. So it's really kind of just a hello world type sanity check. Okay, so that is really all I need to do in terms of like just getting that function set up as just a quick sanity check. We then added the function to our Docker Compose file. So I'm going to go ahead and set up the GitHub webhook and deploy this new function and then see if the webhook is then actually going to trigger, or if the function is going to get triggered from that webhook. So I probably already have a webhook set up in here, but I'm going to delete it. Okay, so if you're doing this at the project level, if you're using GitHub, you just go to Settings, Webhooks, Add Webhook. So inside here, this is going to take a payload URL. It's going to take the content type. I could have like just left it as, I could leave it as like this form encoded and take off the JSON.loads. Let's just use JSON. I always like think in terms of JSON with REST, so I just want to leave it as JSON. And so I'm just going to put in the payload URL, and at this point, I just want to push the event. So this URL is going to be, what is this URL going to be? Let's see, sorry. So it's going to be similar to this. We haven't named the function yet, but it's just going to be that. It's just going to be hook. We're going to replace Docker Machine IP OpenFaaS with the actual IP, but I'm just going to grab this. I'm going to copy and paste this. Pop it in here. So now I just need the actual IP. So that is going to be this IP here. Paste this in here. Now, if you weren't feeling comfortable at this point, like setting up a hook, you could use that eval function. That eval function will take a post request. It will throw back an error at that point because it's not getting the right things. But if you're just looking for a quick sanity check, you could just put in eval here. And then when we test out the webhook, you will see an error come back. But that's good in that case. We're getting an error. It's actually communicating with the function. I'm going to, for time's sake, I'm just going to go ahead and hook up the hook function. And so here, just the events you would like to so which events would you like to trigger? So I just want to do this on a push event. So anytime I push new code to this this repo, I want to trigger the webhook. So I'm going to go ahead and add the webhook. So if I open it up here, I can test this out. Right now it's getting a 502. So it's getting a 502 because the function doesn't exist. So I need to deploy my new stack. So to do that, let's see which Docker machine I'm using. So I'm on my web machine. I need to switch over to OpenFaaS. So Docker machine env OpenFaaS. Grab the eval command. So now I'm going to, if I go back to my notes here, so how did we redeploy it before? Before we just pulled down the stack and then redeployed it. Same exact thing. Pull it down. One thing I haven't done is I haven't built the function yet though. Or I'm sorry, I haven't built that image yet. So I do need to do the Docker build. And let's do hook. And we need to call this Python hook. This name here needs to match up with what you have in your Docker Compose file. So in the Docker Compose file, the image is called python-hook, and it's getting the latest tag. So those need to match up. So I'm going to build that image. This is building on the Docker machine for OpenFaaS that is on DigitalOcean. Image is built. I should be able to redeploy now. So Docker stack deploy func, that looks pretty good. So you can see my hook function. So far so good. Let's go to the UI. My hook function is there. So remember, it's going to take anything I put into the payload here and spit it right back out. So I feel like if I put whatever in here and invoke it, okay, I'm getting null. Maybe it needs to be actually, it might actually need to be correct JSON. Yeah, because it's doing JSON.loads. Good catch. So I can't put whatever in there. It actually needs to be valid JSON because I am doing JSON.loads. So I don't know. Is that valid JSON? So yeah. Cool. So now I can test my webhook. Going back to my webhook, let's redeliver this. 200 response. You can actually see the response that comes back. And you look in the body here. This is literally what is being sent. So I first had the question when I was doing this, how do I know what that object looks like? How am I going to be able to figure this out? I could go into maybe OpenFaaS logs with Docker and maybe take a look at it there. Or by just printing back out what I'm getting, I can take a look at that object pretty easily. So I can copy this out of here and just do like a JSON validator. And so now this is what GitHub is sending me. And so what do we need? We just need the namespace and the repo name. So we just have to parse this thing. And that is going to be under repository. There's a repository name. There's a number of places I can get the actual namespace, but if I'm going to be parsing repository, I can just grab it from the owner login there. Questions thus far? So I'm just doing this in pieces, just getting like a quick sanity check, not trying to like do everything at once. Going back to like the steps here. So, and the function, set up the GitHub webhook in the project repo test. So we're all the way down to here. So we added the function, set up the webhook, got our quick sanity check. So now it's like we know that there's communication between OpenFaaS and or between GitHub and OpenFaaS. Now we just need to actually wire up the functionality that we want. So we want to update this function. So inside here, again, I need to go into so it looks like it's repository and then name. So repo underscore name equals payload. Anyone know how to make this thing go away? I'm using Atom. It just started doing this. Yeah, I think I need to probably reinstall it. But yeah, it's where is that at? Oh well, for time's sake, I'm just gonna pretend it's not happening. Okay, so that's gonna be the repo name. I think was it owner, and then login. I think was where the repository owner login. That's where I'm getting the namespace. So now, if you think back to our eval function is pretty much like wired up to do this. I could then call the eval function here if I wanted to. I don't want to really get into exactly how to do that at this point, so I am just going to grab a lot of the code from here now. I'm just going to copy over my main function. So now, God, that's annoying. So now what I can do is grab this here, plop it in here. So now this should, maybe that's a little easier to see now, with that little thing popping up every 2 seconds. Jeez. So now this should mimic that exact same functionality we were doing in our eval function. So grabbing the payload, parsing it to get the repo name, did the namespace, pop that in here, clone it down, do its thing. But the thing is, we need to, instead of just sending this back, so we can send this back at this point, that's fine. But we also need to send the post request to our web API. But let's not do that yet. Let's just make sure that this is working right now. So we should get back in that webhook whatever is getting popped into here. So let's test this out. Actually, I need to update this. So I need to rebuild. I'm going to pull down the stack, redeploy the stack. And so there's a race condition here, so it'll get in a second. There it goes. Okay, so now if we test this out, so there must be an error. I do that on the right machine. Docker machine ls. It's always fun, live debugging. I am on the right machine. Oh, there it goes. It just took a second to pop up. So let's go inside of here. If we invoke this, I expect to see an error. Yeah, because the repo name is not there. But if I trigger it from my webhook, redeliver this, inside the response, this is actually the tests running, tests are passing, because right now on the right now on the repo, 22 must equal 22. So the tests are passing. So we're getting closer. So moving on, so tests, got a quick sanity check, update the function, deploy the web stack. Okay, so now at this point, the webhook is sending, we're sending the webhook, we're parsing the request, we're running our tests. Now we need to send the results to our web API. And to do this, we can set up, let's just set up a quick route handler. So inside my web views, what is this going to look like? So it'll be a post request. Let me just copy this one. Okay. So what should the endpoint be? What information do we need to actually update a project? So inside the database, there's going to be a UUID. We don't have that UUID because we're sending it from, that webhook is getting triggered. We do have the project name though. As long as that project name is unique, then we should be fine. Now, in this case, you can have project names on GitHub are not unique. They are unique with the namespace though. So if you really wanted to test for uniqueness, you would probably want to get the namespace and the repo name. In this case, I am just going to get the repo name. So, going back to our function here, we're sending status and we're sending data. Let's also send the repo name with that. We have it, it's available. We have the namespace too. Let's send those both back because we have those in our database. Actually, let's just send one back now and just call it quits with that. So with the repo name, that won't be unique like I was saying, but we have that variable. What was that saying to do? Toggle developer tools? I don't know. Okay. Okay, so we have our repo name there. So now, actually, my bad, we don't need to send this back here. We need to actually send this using the request library. Let's see, let's do it right here. So r equals requests.post some sort of URL. I found out the other day, instead of saying payload equals with request, if you say JSON equals, it'll actually stringify it for you and change the application MIME type to application JSON, which is super awesome. I don't know if that's a new thing, but we can say repo name. So what do we need here? So we just need the repo name, and since the end user is not going to see anything, because typically, this is probably coming from a webhook. We're not like setting this up in like, real time at this point. Kind of like, Travis CI will display this stuff in real time. Let's not worry about the real timeness. Let's just update the database whether that project is true or false for the status, whether the test passed or not. So, JSON, repo name, and then I'm going to pass the status back. I'm doing too much JavaScript. Forgot that there. Okay. So I'm pulling in a library here, request library. This must be just like, but pulling in a library here, the request library. We could use Eurolib 3, but let's just add requests to our requirements. So this endpoint now, what does that endpoint need to be? We can just hard code it in for now. Probably don't want to do this. All right, so we're coming up on 10:19. If you need to leave, obviously, go ahead and leave. How long is this room open for? Another hour. 12:30? Okay. All right. So let me. I think you all understand the direction I was heading in with that. It just needs to be wired in more. I do have another challenge here for creating the build history. We'll just go ahead and knock that out in 30 seconds. Just kidding. I was going to show monitoring, but so I guess just wrapping up. I do have some additional challenges here. Sorry, I didn't get into the actual securing as well. A lot of like stretch goals there I didn't get into, but you probably want to look into securing your OpenFaaS functions. If you're going to be deploying in a production environment, you just pop Nginx on top of it. There is a nice little OpenFaaS workshop here. Highly recommend going through that if you want to learn more about OpenFaaS. Really good workshop. Since you have a lot of context now of OpenFaaS and like how you write your functions and whatnot, it should be pretty easy to go through that. Obviously go through some of the remaining challenges. Slides are here, repos here. Check out testdriven.io if you want like a full course on this type thing with microservices. 12-factor app, highly recommend reading that for Docker cheat sheet. So that is all I have. I'm super surprised my voice is still here. I'm kind of curious, like let's just keep going with it. Let's see how long I can talk for before my voice goes out. But yeah, really appreciate you all being here.